Hi everybody, so in this video we're going to look at finding the interior and the exterior angle of polygons, and as we progress through the lesson we'll involve multiple angle properties within a single problem. Okay, so for example A, we've been asked to work out the exterior angle of this regular pentagon. We know it's a pentagon because it's got 5 equal sides. So because it's an exterior angle, well, if I was to draw an exterior angle on each vertex, we can see now the exterior angles rotate around the point or rotate around the circle. So as we go from this angle and this angle and this angle and so on around, we're creating a circle. So all of these exterior angles, which are all equal, they're all angle A, they would all add up to 360 degrees because they're rotating around a circle. So with 5 equal angles, so 5 lots of angle A will equal 360. So we can work out angle A on its own by dividing both sides by 5. So these will cancel, and angle A will be 72 degrees. And if we know the exterior angle, well, we can calculate the interior, so this angle here, which is the same as angle C in question B. So we can see that angle A, the exterior angle, plus the interior angle, add together to make a straight line. So if we just make a note of this, then we can work out angle C because A plus C will equal 180. We know angle A, we just worked out our 72 degrees. So plus angle C will be 180. We can take 72 away from both sides. And these will cancel. So angle C will be 180 take away with 72, or 108 degrees. So this is this angle here, which is the same as this one. Okay. Let's move on to question C. Okay, so in this example, we've been asked to work out the interior angle of this regular hexagon. And in question D, you've been asked to work out angle D of this nonagon. So if you want to try these questions yourself, you can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we're going to do is we're going to look at the exterior angle of this hexagon, because we know all the exterior angles around the hexagon will add up to make 360, because they rotate around a circle. If we call this one, let's call it X. So 6 lots of X will equal 360. So the exterior angle divided both by 6 will be equal to 60 degrees. So we know this one is 60. Now we can work out the interior because they lie along the same straight line. So 60 plus the interior will be 180. So angle C will be 120 degrees. Okay? For question D, well, this isn't an exterior angle, but what we can see is that this angle and this angle, the interior angle of our nonagon, let's call this angle N, well, these two add together to form a circle. Angles about a point will make a circle. So N plus D will make 360 degrees. So now the question isn't about working out angle D. The question now is about working out the interior angle, angle N. And we can work out the interior, let's say this one here, just to save space. We don't need them the same because it's a regular polygon. But we can work out the interior by working out this exterior, which will be 360 degrees divided by the number of exterior angles divided by 9. So this will be 40 degrees. So 40 degrees plus the N form together to make a straight line. So N must be equal to 140 degrees. So if we know this is 140, we can work out angle D by putting N into here. So therefore, 140 plus D will make 360. So D must be equal to 220 degrees. Okay? In our next question, we're going to combine together multiple angle properties. Okay, so here we've got a problem-solving type question. We've been told that the diagram shows two congruent regular heptagons touching inside a rectangle. We've been asked to work out the values of the shaded angles. So this green angle here and this red one here. So do you want to try this question yourself? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we know this is an isosceles triangle, because if I just use a highlighter, you can see that this line here would be the exterior angle joining this interior angle. And you would have another exterior angle on the other heptagon, so here. So each of these two angles must be equal because they're joined by congruent heptagons. So we can work out this angle, just rub this out, as 360 degrees divided by 7, because all exterior angles are the same, and we've got 7 of them. So this will be 51.4 degrees. So this is 51.4, and so is this. So now we've got this isosceles triangle, we can work out this green angle if we just sketch this over here. This is 51.4, this is 51.4. We can work out this angle as 180 minus 2 lots of 51.4, which gives us 77.2 degrees. And this is the green angle here, 77.2. Okay, so moving on to this red one, well, we can see that this green one, this one in our heptagon, this interior angle, is the same as this interior angle, and all four add together to make 360 because they join about a point. So what we need to do now is work out this interior angle. But we can do this because we can work out this angle. And these are the same. And these two add together to make a straight line. So this interior angle will be 180, take away the 51.4, which gives us 128.6. So each of these are 128.6. We can now work out this red one as 360 take away with two interior angles, take away the green angle 77.2, and this will give us 25.6 degrees. Okay, so in this example, it was all about putting different angle properties together to solve a bigger problem. We're going to attempt something similar in our next example. Okay, so in our final example, being told that the diagram shows a regular hexagon which overlaps a regular octagon. And we've been asked to calculate the value of P, to this angle here. So again, maybe you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we need to do is we need to realize that each of these two angles are the same, because they are both the interior angle of this regular octagon. We can also see that this angle is an angle in a regular hexagon. So what we need to do is work out these three first. We also know that this side is the same length as this side and this side. Again, because they're the sides in a regular octagon. And this length is the same as this one, because they're inside a regular hexagon. And because these two are equal and these three are equal, this angle P will be the same as this one. Okay, so the next thing we need to do is to work out each of these interior angles. Well, we can work out this one because we know the exterior will be 360 divided by the number of sides, or the number of angles, so divided by 8. And this will give us 45 degrees. So the interior will be 180 take away the 45, 135 degrees. This one as well. This interior angle lies along a straight line with this exterior, and this one will be 360 divided by 6. This will be 60 degrees, which means this interior will be 120. We can find the sum of the angles in a pentagon by working out one interior angle and multiplying it by 5. So if we've got our interior, which we'll say is here, this is our interior. Our exterior will be 360 divided by 5, 72. The interior then will be 108. And we've got 5 lots of that, so 5 times 108 will give us 540. So we know the sum of these 5 angles will be 540. So 540, take away 2 lots of 135, and the 20, 120, will give us 2p. This will work out as 150, which is 2p. Divide both by 2, so p will be 75 degrees. Okay? Well, thank you very much for watching, and I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.